Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic chemical families. And the subtopic for today will be alkali metals. So we are still continuing with the chemical properties of alkali metals. Previously, we talked about how alkali metals behave when they are burnt in air and how they also react with water and also moisture in the atmosphere. So for today, we look at the reaction between alkali metals with chlorine, and then we're also going to look at some of the uses of alkali metals and then finish up the lesson with some few questions. So when you look at the reaction of these metals with chlorine, you notice that when these metals react with chlorine, they form the metal chlorides or corresponding metal chlorides. So generally, when you look at the procedure, is that a small metal is placed on a diffractating spoon, which looks like this, and then we put that small piece of metal here, and then it is warmed and lowered into a gas jar. So it is lowered into a gas jar containing chlorine gas, and then it's allowed to heat this jar. So it looks like something like this, and then the reaction is allowed to proceed. So one of the precautions we take for this experiment is that the reaction should be done in a fume chamber. The reason why the reaction is done in a fume chamber is because the chlorine gas that is being used is very poisonous. And if the fume chamber is unavailable, we recommend the reaction to be done outside in an open air space. And then when we are doing this reaction, we do not do the reaction of potassium with chlorine in the laboratory because it's very explosive. We say that potassium is one of the most reactive metals among the 20 elements. So when you look at the other metals, that is sodium and lithium, sodium usually bursts into a yellow flame when it reacts with chlorine, and sodium chloride is formed. So this is the equation. Sodium reacts with chlorine to form sodium chloride, and then for lithium, it's not that reactive, or it doesn't react vigorously as in the case of sodium, and doesn't burst into a flame, but it produces white fumes of lithium chloride. So you can see from the equation, lithium reacts with chlorine to form lithium chloride. So for potassium, in the cases where the reaction has been done in a controlled environment, not in the laboratory, in the school lab, so it's burst into a lilac flame, just like it did when it reacts with oxygen. And then it produces white fumes of potassium chloride as well. So this is the equation for the reaction. And then when we have just been looking at the chemical properties of alkali metals, so this brings us to the conclusion that the reactivity of alkali metals increases down the group. So we say that it increases down the group because if you look at the size of the atom, this is just a sketch of the size of the atom. I want you to see the difference. So alkali metals usually react by losing a single valence electron. So when we are discussing about the reactivity increasing, we are looking at how easily does that outermost electron get lost. So the ease of loss of the valence electron increases down the group. So it is easier to lose in potassium than it is to lose in sodium and in lithium. So the ease of losing increases down the group due to the increase in the attraction of the valence electrons towards the positive nucleus. So you see the outermost electron is attracted very strongly in lithium, and in sodium it is attracted weakly. In potassium it's even weaker. So you can see the ease of loss. It will be easier to lose in potassium than it is to lose in lithium. This in turn is due to the increase in the atomic radius down the group as a result of the increase in the number of energy levels. So you see how those three are related. Increase in the size of the atom causes increase in the loss of electron in the outermost shell, because there is a decrease in the attraction between the nucleus and the outermost electron. So that's the reason why the reactivity increases down the group. So next, we are going to look at some of the uses of these alkali metals. But before we look at the uses, we are going to look at how some of the formulas of these products are. When you look at generally the valency of alkali metals, they usually have a valency of 1. That's the reason why, because they lose 1 electron in the outermost shell. So most of their compounds will have that valence. So if you were to form, for example, lithium hydroxide, it would be lithium OH. So make sure you go and check out. We did these formulas in a different video. And so make sure you go and check that out. If it's sodium, it's going to be the same. You notice their valencies are the same. So if it's lithium oxide, it's going to be lithium with a 2O because the valency of oxygen is 2. Then sodium is going to be the same, and also potassium is going to be the same. For chlorine, since both of them have valencies 1, 1, so it's going to be lithium chloride, then sodium chloride, then potassium chloride. And for sulfates, because they have a valency of 2 like oxygen, it's going to be just like oxygen. It's going to form lithium sulfate, then sodium sulfate, and potassium sulfate. This is just samples. There are so many other metals or ions that they can react with. These are just samples to show you because they have 1 valence electrons. They usually have a common general formula when you're writing their chemical formula for the chemicals they are formed. Next, we look at a few uses of alkali metals. Whenever you are told to give a use of an alkali metal, you give a specific use. Do not say that alkali metals are used for this and this. Be specific. Lithium is used for this, and then sodium is used for this. Potassium is used for this. Do not generalize. So sodium is used in the manufacture of sodium cyanide for gold extraction. Lithium is used in manufacture of high strength glasses and ceramics. And then lithium is also used in the manufacture of dry cells. You're going to talk about these dry cells later in Form 4. And then a mixture of potassium and sodium in molten state is used as a coolant in nuclear reactors. And then sodium vapor is used to produce a yellow glow in street lamps. So it is used in advertisements, those advertisement lights that you see on the streets. And then molten sodium is used as a reducing agent in the extraction of titanium. Sodium chloride is also used as a food additive. This is one of the easiest uses because we use it in the house. And then a mixture of sodium hydroxide and carbon disulfide is used in the manufacture of rayon, which is a silk, artificial silk. So then we look at a few questions. The first question is state 3 uses of alkali metal and their compounds. Remember, we said that you have to be specific. So you can pick any of these uses that we have discussed. Sodium, lithium, you can also look at the mixture of sodium and potassium and how they are used. And then question 2 is the table below gives the energy required to remove the outermost electron from the same group, basically ionization energy. Arrange the elements in order of their reactivity, starting with the most reactive. So basically, we have been given ionization energy, and then we are told to tell which one is more reactive. So we said for metals, their reactivity is loss. It's all about loss of electrons. And loss of electron is directly related to ionization energy because this is the energy that is required to lose these electrons we are talking about. So if the ionization energy is very high, it means it's not that easy. It's not easy to lose an electron. If the ionization energy is low, it means it's very easy to lose an electron. And remember, if it is easy to lose an electron, then it means that it is very reactive. That is just a summary. So when you look at elements 1, 2, 3, and 4, when you look at their ionization energy, you notice the one that has low energy, you start with the one that is low energy, because they have said you start with the most reactive, and the most reactive is the one that has the lowest energy. So the lowest energy is element 4, followed by the second lowest is element 2, and then the third lowest is element 1, and finally the highest is element 3. So element 4 is the most reactive, and then element 3 is the least reactive. So you put it, it can be up or going down, it's okay. So the element 4 is the most reactive, element 3 is the least reactive. So this brings us to the end of this session. So we have closed off on alkali metals. I hope you have been able to understand the properties and also the uses. The next thing that we are going to discuss is on alkaline earth metals, another chemical family. So watch out for that.